array, and what is the use of array, why we are using array, some properties of array, then how to declare array. So today we will discuss part about this array. So the declaration of array is like this. First you have to declare the data type. So just a recapitulation of array, that array is similar or homogeneous type of data, homogeneous or similar type of data. Array is static memory allocation. Array is contiguous memory allocation. Okay, then array have index value, which is from 0 to the total size minus 1. Then contiguous also having the meaning like adjacent. So these are the more or less the main properties of an array. So how to declare one array? The declaration is like this. First you have to declare the data type of the array. Then you have to give some array name. Okay. And then you have to use this operator, which is called subscripted operator, or sometimes called array operator. The actual name is subscripted operator. And then you have to give the size. Okay. So this one is subscripted operator, which is mainly used for representing array. Okay. Now remember, this array name is very peculiar in case of array. This array name. Why? Because if you print the array name only, the value of array name, then it will give you the base address or the starting address. Base address, or you can say starting address of the array. So that's why it is so peculiar. Then this is called the offset. This is not size actually, the index value. The index value is nothing but the offset. It means you are, suppose this is your memory in RAM. You are in this position. You are in this position, which is nothing but called the base address. And from that address, what is the offset? What is the distance? If this is the distance and the location or the element position is say I, then we have seen in the last class that the address of this one will be like this: A plus I into size of, what is size of? Size of is again an operator to give the size in bytes of the data type. So in using this formula, we can easily calculate the address of any element. So this is equal to address of AI. So try to remember this thing, because this is very important. This is very important in case of array. And so that's why we can say that since array name itself is a base address, so what we can say that array is a collection of memory location. You can say collection of homogeneous memory location. Homogeneous memory location. You can say this. Nothing wrong with this memory location. So this is very important in case of any array. Now how to access any element of array? It is A of I, and which is called like this: ith element of array A. Now, I have in last class I have also told you when we should go for array. Since array is static, it means we have to define the size before its declaration. So at the time of declaration, you have to provide the size. You cannot provide the size at the runtime. You have to give it in the compile time. That's why it is also called static. You cannot change it. So when we will definitely go for array, if we already know we have to use more than one same type of variable, we have to store the value of the variable till the end of the program, and we already know how many elements, then we will definitely go for array. So when we will go for array, if we are using a set of similar types of variables, okay, and we need the values of those variables till the end of the program, and another and we know the size, then definitely go for array. Okay. Now if this part is not known, you don't know, this is unknown, and I have told you that if it is unknown, then there is a two possibility. But if I use array, there is a two possibility. We know the size, we will definitely go for array. If we don't know, then also we can go for array. But in that case, if it is unknown and we are still using array, then we can have two problems. One is called shortage of memory, another is wastage of memory. But remember, in case of our C language, shortage of memory does not happen. Why? Because C language did not, you can say not, better, does not check. See, this is very important. The boundary of the array. This is very important. In C language, there is no possibility that you can check the boundary of the array. Boundary of the array means if I define an array, integer array of size 5, it means the index value from 0 to 4. Only this index value will be allowed. Not any other index value, just like -2 or +5 are not allowed. But in your C language, you will see that you can use this also, this also. It means there is no checking of the boundary. Okay, that's why shortage type of thing not that much effective. But wastage is definitely, because when this type of wastage will occur, suppose you don't know the size, user will give the size. So that's why you have already declared array size of 100. And suppose the user give input for number of elements which is 10. So then definitely there is a wastage. Why it is wastage? Because you have already occupied 100 elements from the stack, and still other programs which are not able to allocate those memory. then this is called wastage. So this is definitely happened, but this shortage not actually happened due to this property that in C language there is no checking of the boundary of the array. Okay. Now, if we, so better solution for this unknown kind of thing, the better solution is go for dynamic memory allocation. Now, what is dynamic memory allocation? The actual meaning of dynamic memory allocation is memory is allocated at runtime. Okay. Now, why this is better? If it is unknown, why this is better? Because if we allocate memory after knowing the size of the array, then it must be in runtime. Why? Because after getting the size, user giving scanf %d %n, the number of elements, then I am allocating integer a of n. Then this is called runtime allocation of array. In some language, some compilers support this, but this is not actually array. This is again why I am able to write this and as well as write this, because array is nothing but collection of homogeneous memory allocation. You are allocating nothing but the memory. From base address, you are allocating some linear number of elements. That's why this is possible. So this is some definite ideas about array, and now we will start declaring array. Suppose I am going to declare integer array, say 5 elements. Okay, and in my program, if I want to print the name of the array, I've already told name of the array means it will print the base address. So since, remember this thing, if it is address, then it should have a long size. Okay. So in case of address printing, we better use %u for unsigned integer. It is for unsigned integer, means it will be always positive. What does it means, unsigned integer? So in normal integer, which is called signed integer, if the size of the integer is 8 bits, then first bit, the most significant bit, is allocated for its sign information. Rest 7 bits are for storing the data. This 7 bits are for storing data. Okay. Now, if this most significant bit, there are 8 number of bits. If this most significant bit is 1, then we say it is a negative number. If this bit is 0, if the bit is 0, then it is a positive number. So this is the meaning of signed integer. It means in case of signed integer, you are only having 7 bits to represent your data. So what is the range? How much you can represent, since there is only 7 bits, so 2 to the power 7. And what is the value 2 to the power 7? It is 128. Okay, so from minus 128 to 127, you can implement using this 8-bit sign integer number. That's why you will see in your book there is a range of value minus 32,256 like this to up to this. So this is the range. But if it is address, then it should be unsigned integer. Unsigned integer means this bit is not there. In case of unsigned integer representation, this bit is not there. So all the 8 bits will be used to represent the data. So how much you can represent? You can represent 2 to the power 8 is 256. Okay, it means the value range is high in case of unsigned integer rather than the signed integer. Okay, so better for printf, whenever we are printing address like thing, suppose there is one variable x and I want to print the address of this variable, then better go with %u rather than %d, because %d is representing signed integer decimal values and %u is representing unsigned integer. So you can understand that if the address is, suppose the address is 212, the address value is 212, then using this, it is not able to represent. The signed integer format will not represent this 212 value. Why? Because it has a range of 128. Okay, so this value, this 212, which is an address, will be represented in a different value. But in case of unsigned integer, we can easily use this 212 to represent, because it is, the range is 256. I am considering 8 bits. If it is a 16 bit or a 32 bit, according to that, you have to modify the range values. Okay. And why we are using in case of address %u, another reason is address always must be positive. That's why we are using %u. So whenever we are using address %x, suppose I want to know the address, then better use %u. Why? Because if you use %d, it may happen that actual 212 will be converted to some other value, because it does not satisfy the range of the value. But if you use %u, it will definitely print the exact address value. Okay, that's why sometimes when we are print the address with %d, sometimes it will show a negative number. Why? Because due to the increase of value in there, this bit may be 1. Due to, if I convert this into binary bit, this bit becomes 1. So it becomes a negative. So that's why sometimes it gives us negative number. So for address, better use %u. Okay. So many things I have told for just a single thing. Okay, now just remember, better use %u for this type of things. Okay. Now the next thing that I am going to discuss, that if I print for this particular array, if I want to print the value, say value of first element is a of 0. Okay, what it will print? Okay, now see, I have only declared the variable, only declared the array. It means in memory, if 5 elements are allocated, okay, 5 elements are allocated. The name of this allocated location is A, and each element is accessed by subscripted variable with index value this. So what is the name of this location? The name of this location is A of 0. What is the name of this location? It is A of 1 in this way. This is the A of 4. So only this thing happened. It allocates some memory. But in memory, since we are using the same RAM memory again and again, we are running, we are compiling and using the same memory. So there may be previously used memory locations. There may be previously used memory location, and some previous program or some previous operation or job have assigned some values on those memories. So you will get some garbage values from these locations. If I print without initializing an array. It will print some garbage value. So there it will print some garbage value. Logic clear? Now the question is then how to remove this garbage value? If you want to remove this garbage value, then the solution is you have to at the time of declaration, if you allocate one of the variable as 0, this is called initialization of array. This is called initialization of array. Okay, if you allocate only one element with 0, then what happened? All the other elements become 0. Remember this thing. If you allocate only one element by 0, see there I have allocated only the first element. Remember, if I give only 0, it will allocate only in the first position. Instead of 0, if I put here 6, then remember this 6 is for only the first element, the 0th element. Other elements automatically become 0. So this is the simple initialization of all the elements in an array. If you want to initialize each and every element of the array at the time of declaration, then definitely you have to write it like this: int a 5 equal to, say I want to initialize it with the first few prime numbers. Okay, so 2, then 3, then 5, then 7, then 11. So I have 5 elements. So I have allocated the 5 elements with this value. So this becomes 2, this becomes 3, this becomes 5, this becomes 7, this becomes 11. Logic clear? Now the next thing, suppose I have declared an array of 5 elements and somehow I want to initialize more than 5. You can initialize less than 5. That is okay. The rest element will be initialized with 0 value. But if you initialize more than 5, then it will give you error. It will give you error. This is not possible. So that's why in some cases we don't put any variable or value or size here, and just we initialize the variables. Just we initialize the array variables. And then in that case, this size will be automatically assigned from the allocated variables. If number of allocated variable is 5, then definitely the size of the array is 5. But if you already defined 5 and you want to initialize more than 5, then it will give you error. Less than 5, no problem. Less than size, no problem. Rest will be initialized with 0. Now just try to see very interesting thing. Suppose I have declared one variable like this, array variable like this, and then I have only initialized the first one. Okay, and in second case, I have initialized it, the first element, only the first element with 1. Now in this case, if I want to print a of 1, what is the value of a of 1? And in this case, if I want to print what is the value of a of 1, then remember this will print garbage value and this will print 0. That's very interesting. Why? Because this initialization is called runtime initialization. Logic clear? But this initialization is called compile time initialization. So that's why when at the time of compilation, when actually we are allocating the memory, if at that time we initialize with some value, then the uninitialized variables will be automatically converted to 0 value. But in the case of this, where the allocation or initialization of variable is at runtime, then the rest variables will be as it is, that is the garbage value. So just remember these things. Okay. So if you want to print the address of any element, you can definitely use the address operator. And if you want to print the value, so if we want to know the address of ith element, then you have to write it like this. If you want to the value of ith element, then you have to write it like this. Okay. Now, so this is all about 1D array. So there is the next thing that is called 2D array. Okay, which is nothing but a matrix. And I hope you will understand how to access the memories in this array. This is very easy. Just try to understand. Okay, so how to input, how to input. Okay. Now, so to take input, we are going to use some for loop. I equal to 0. This represents the index value. I less than, say, if the size you already know. If you already know the size, then better. If you don't know, if it is unknown n, then you have to write it according to that. Okay. Then we use this type of printf statement, but it is not necessary. Enter the %d element. Means I want to give the idea that this is the first element or this is the second element, like this. I want to give the idea to the user, +1, +1. Then scanf, okay, %d ampersand a of I. Okay. If you run it, it will print like this. Enter the one element. Why? Because I have printed the value I +1. I is initialized with 0. Okay. Then I will give some value here, and cursor will blink here. If I give some value here and then put enter, it will move into next iteration. Enter the two element, like this, or you can write it this format, in this format also, a of %d and the value of I. Then it will print like this, a of 0 element, then a of 1 element, like this it will print. Okay, this is how to take input. So remember, this ampersand is very important. Since you are taking input, this ampersand is very important. And how to give the output? So again, you have to run a for loop in case of output. In case of output, again you have to write a for loop, and just you have to print the value. So how to print the value? You will print the value like this, printf %d a of I. Done. So this is the way how you can access the, how you can, so this is access of array. Now I will give you one trick how to solve the problem of the wastage and sorted problem of array. See, this is very interesting. Suppose I have already defined an array of size 10. It means I'm not going to allow more than 10 elements. Okay. So inside the program, when the user is asked to give how many elements, so printf enter the number of elements So this is the solution how you can solve the wastage and shortage problem in case of static array. So this is static. See, I've already defined. So I'm not going to allow more than 10 elements. So how I can solve this? That there should be no shortage or wastage. So after that, the user will give the value, how many elements, that is n. Now see what I am writing. If n, now see, user can give negative value for number of elements. So I'm not going to allow that. So if n is greater than 0, you are only allowing greater than 0. Greater than 0 means at least one element array is allowed. N equal to 0, user can give also n equal to 0. You are not going to allow that. If at least one element is given and n is less than equal to 10. If this range is there, if your given n is within this range, then you can go for further operation. So it means if it is not giving in this range, you should repeat. You should repeat. So I am putting this whole thing inside a do while loop. Now you can understand where we should go for do while loop. If this is happening, then I will break the loop. And if it is not satisfying, then it will print one statement, improper input, try again. Okay, you will print this statement and then you will complete the while part, where while is always true. It means it is infinite loop. Basically, it is infinite loop. When it will break? If you give proper n value. If your given n is satisfying this range, n, suppose you have given, suppose I have already declared this 10, suppose I have given n equal to -5. Is it satisfying? No. So it will print improper input, again enter number of elements. Again it will take value. Suppose in the next time I have given 15, not range. So again improper input, try again. Logic clear? Now in the next time I have given 10 or I have given say 6, so satisfy, so it will break. So in this way I can overcome the problem of shortage. Okay, and see, since I have declared a very small amount, only 10, so you can say that I have also solved the problem of wastage also. It is not that much wastage. What is the minimum value that I am allowing? I am allowing 1. What is the maximum value? 10. So what is the maximum wastage value? It could be 9. It is not that much. I have declared 100 and I am allocating 10, then the wastage is 90. Na? 9 is better than 90. So this is also called boundary checking. See, I have declared 10, so it should have some range, not over the boundary. Okay, so in this way you can solve this problem. So there's only 2 minutes. So after, uh, if you have any query up to this, you can ask me. In the next hub, I will move into 2D array. If you have any query, you can ask me. Please. Any query? no query. So I could move to array. So 2D array is again, remember, is nothing but matrix. So the picture of 2D array is like this. So if I disconnect, please rejoin. If I disconnect, please rejoin. So there are, since it is a matrix, so row and columns. Row in the side, columns in this side. So how to declare data type.